webinars. And let's crack on with the lesson itself then. So what we're going to do first is I would like, please, for you to, with the piece of paper or your whiteboard or whatever you've got next to you, I would like you to have a go at this question. I'd like you to have a go at calculating the kinetic energy of a toy which has a mass of 25 kilograms when it's moving at 10 meters per second. Now, I've given you the equation there, which is 0.5 times mass times velocity. Remember, velocity just means speed squared. If you are doing this in your phone as a calculator, that's absolutely fine. But if you do it in your phone, can I suggest you do the velocity squared bit first and then multiply it by the mass and 0.5, because otherwise you may throw it out. And I'm going to give you about a minute to have a go at that, and then we're going to go through it together. And I'm going to show you exactly how I would lay that out. So 1 minute, off you go, year 11. If you get an answer and you feel confident enough to share it, please pop it in the Q&A and I can see it. If not, don't worry. I'm going to show you how to do it in a second. Okay, so what I'm going to do now is I am going to share, now bear with me because I'm really trying to do this quickly, but I'm going to share my iPad screen so I can show you exactly how I would lay out that answer on an exam question, okay? So your question said that a toy was moving. Let me just make sure I'm actually using a pen here, that your toy was moving at 25, sorry, was 25 kilograms, I should say, okay? Now, that is the mass. And in an exam question, it's always quite useful to make a note of that, just so you can be aware. The next thing the question told us was that the speed or the velocity was 10 meters per second, okay? And I'm going to write that down as speed, but I could also say velocity, because remember, those two broadly mean the same thing. Velocity is a vector quantity though, and speed is scalar, and we'll get to that at another point, but that's in P2. Now, the equation that I'm going to write out first is kinetic energy is equal to 0.5 or a half times mass times velocity squared. Now remember, the next line in my equation, the next line in my working out that I need to do will be the rearranging. And we need to think, do we need to actually rearrange this equation? And actually we don't, because the question asks us for kinetic energy. So what we're going to do is we're just going to keep as it is. We're then going to plug in the numbers. So we're going to write 0.5 times my mass, which is 25. And I've been really, really lucky here because I don't need to change that mass into grams because it's already in kilograms, which is exactly what we want. I'm then going to multiply that by my speed squared. Okay. Now, if you put that in the calculator as it is, you're going to get the correct answer as long as you do it properly with the squared sign. But if you were on your phone, what you might have wanted to do is to quickly do this. Now that 100 is just 10 squared, okay? It's just a little bit easier. So now if I do 0.5 times 25 times 100, I'm going to get an answer of 1,250. Now remember, you are allowed a calculator in your exam, so none of this is about your mental maths, okay? And well done to that person in the Q&A who got the correct answer. I don't know who you are because you posted it anonymously, but really well done. Now, the last thing I am missing here is my unit. And the unit of energy, any form of energy, is going to be joules. Okay. Now, in an exam, that's either going to be 3 or 4 marks. All right. So that's a really, really good example of that question. Okay. So what I'm going to do now is go back to our PowerPoint and carry on going through our work. So well done, those of you who got the correct answer. It's brilliant to see lots of you having a good go. Okay. Now, what we need to look at today is energy resources. And actually, this is a really nice topic, Year 11, because it's something that you know quite a bit about already. So what I'm going to do is I'm going to go through the theory with you, and there's not much of it. We're going to talk about why it's so important that we know these things. And then at the end, I'm going to go back to the iPad, if you can bear my handwriting. We're going to do exam questions together. Okay, so we're going to look at what the examiner actually wants from you, and we're going to write them together. So hopefully this will be a really good chance for you to practice your exam technique in a nice low stakes way. If you are somebody who likes making notes, you may struggle to make notes as we go along, but don't worry, these slides, I've deliberately put everything you will need on them so you can go back and make notes from them separately. So first of all, what is an energy resource? Well, an energy resource is a way that we generate electricity from either renewable or non-renewable resources. So electricity is an energy store, an energy transfer that we use lots and lots of. Okay, we use it to power our homes, we use it in transport, we use it in heating, but we have to get that electricity in some way. And today we're going to look at how we're actually going to generate that electricity in the first place. Now, guys, if you pop your hands up, it's much easier if you write your question in the Q&A, just because Ms. Wansell and I can sort of answer it between us. If not, at the end, I will do the any hands up questions at the end where I can actually talk to you one-on-one. All right. So the first thing we're going to do is we're going to do a little poll. So what I want you to answer for me is this first question. What is an energy resource? Let's see how many of you are wide awake and paying attention. Is it an energy store we directly transfer from? Is it a type of energy transfer? Or is it an energy store that we generate electricity from? So I'm going to give you about 30 seconds. Do have a go. It's completely anonymous, guys. No one's going to see who's answered what. I wouldn't put you on the spot like that. It's just to see how we're going. Well done to 6 of you who've had a go. The other 6, okay, I'll take that back, 8 of you. The rest of you, be brave. Okay, so I'm going to stop there. And I'm going to end the polling and just share the results. So most of you have said it's an energy store we directly transfer from. And when I wrote this question, I knew that I was going to end up getting tripped up between the two. Now, yes, we do transfer from this store. But what we do is we actually generate electricity through lots of different energy transfers. Now, don't worry, that's not likely to be an exam question because it's quite a confusing one, but I just wanted to see how we're doing. So today we're talking all about how we can use Earth's natural resources to generate electricity. Okay, so let's move on. Today we are going to talk about 2 types of energy resource, and I want to know if you know which 2 types of energy resource there are. Off you go. Are they light and sound? Are they renewable and non-renewable? Are they ones that are environmentally damaging or safe? I'm going to give you only 30 seconds for this one because I think I've already mentioned this and I probably should have remembered that when I wrote the poll. So I've got 8 already. There are some of you who are just sliding under the radar, keeping your cards close to your chest. Well done, 9. Okay, the answer, ladies and gents, is in fact renewable and non-renewable. Light and sound are types of energy store, but the 2 types of energy resource we're going to look at are renewable and non-renewable. Now, I put the environmentally damaging and safe option in there because some people think renewables are super safe, they're not damaging to the environment at all. And in some ways, you're right, but there are issues with them too. So we need to look at all of that individually. So the two main types of energy resource we need to know about are non-renewables and renewable. Now, non-renewable resources are called non-renewable because they will eventually run out. And that is your major definition of a non-renewable resource. Now, the ones that we talk about mainly tend to be your fossil fuels. And fossil fuels include coal, crude oil, and natural gas. Now, they're called fossil fuels because they're actually made from the decay of old living things deep underneath the ground for millions of years. And because it takes millions and millions of years to form fossil fuels, they're non-renewable. I dig them, or not me personally, but we dig them out of the ground and extract them from the ground far, far quicker than they could ever be formed. So they are non-renewable. Nuclear fuel is another example of a non-renewable that we talk about. And nuclear fuel normally is uranium, which is a radioactive material, and we use it to create lots and lots of electricity. But again, it's non-renewable. It's a resource that there's only a certain amount of on Earth. And once we use it, we're done. And so that's why we've got to be really careful. Now, in general, renewable resources include ones that are not as harmful and not as polluting, but some of them can be a little bit in terms of visual and noise, but we'll go through specifically. Now, these do not use up natural resources or use resources that we can't then replenish. So renewable resources will include things like biofuel, where crops are grown specifically to be used as fuel. Now that's using them up, but we can replenish them, we can plant them again. It doesn't take that long for them to grow, and we can get that resource back again to use again. I said again a lot of times there. Now, specific ones that we need to be aware of, at least the name, and we're going to go through some details in a minute, are biofuel, wind, hydroelectricity, geothermal, tidal, solar, and wave. And we're going to go through a couple in more detail, but I've got a lot of information on some slides for you to make flashcards, etc. out of in your own time and for your revision this week. So let's have a little go at who can see that difference between renewable and non-renewable. So there's a poll here now, which has got 4 questions, 4 different types of energy resource. I want you to decide whether each one is a renewable or a non-renewable resource. So we've got natural gas, got solar power, got nuclear fuel, we've got biofuel. So far, pretty good. I've got 3 of you so far who've answered. And this is just to get you thinking, okay? I don't expect you to be an expert yet, but we need to start being able to work out exactly what's what. So come on, guys, I've not got all of you yet. I want more people answering this poll. Well done, those of you that have done it. The first question is 100% correct so far. Excellent. Brilliant. Okay, I'm going to end polling and I'm going to talk you through the results. Now, some of you, I think, got a bit confused with 1 or 2 of them, but let's go through the right answer for each of them. Now, in each case, the correct answer was the majority, the one that the majority got right, which is fantastic, year 11. So natural gas, the gas that we can extract from the ground, is non-renewable, okay? It's found deep within layers of rock under the ground. Once we take it out, we can't get it back at all, unless we wait millions and millions and millions and millions of years. Is solar power renewable or non-renewable? It is renewable. Fantastic. Our sun is not infinite, but it may as well be for the amount of energy that it gives out for now. Is nuclear fuel renewable or non-renewable? It is non-renewable, okay? Once we run out of uranium and our stores of uranium, then we are unable to continue producing nuclear power. And lastly, biofuel. Biofuel is renewable, okay? It is renewable because it's a type of fuel that we get from growing plants and allowing them to rot a little bit and then burning them. Now, don't worry if you didn't do particularly well on that, because we're going to go through that now. And I'm going to take you through the 2 non-renewables we've looked at and then a few renewables. And the reason I'm going to take you through some, but not all, is because firstly, we'll be here all day. And also because lots of the information is applicable to lots of different types of energy resource. And we'll start to see that there are patterns that we need to learn when it comes to answering questions. The things that you need to know, and I've taken this exactly from the exam board, describe what it is. So do you actually know how to describe what a fossil fuel is? That's the first thing you'll need to be able to do for all of the resources. You'll need to be able to tell me whether it's renewable or non-renewable. You need to also be able to say, how is it used? Okay, so is it used in a power plant? Is it just used to turn a turbine there and then? And lastly, you need to think about the disadvantages. So what are the environmental impacts? Now, I've done some slides for you, which model a really good way of revising it. And then I'll show you a big table at the end with all the information you could possibly need. So the first one, and the first ones, I should say, that we're going to talk about are your fossil fuels. And they include coal, oil, and natural gas. Now, first and foremost, they are non-renewable. Once we've run out, we're done. And we are getting to the point where our resources are really scarce of these things. We're really trying to move away from using fossil fuels for a number of reasons. So as I said before, they're made from the remains of organic matter that has decomposed over millions of years. They're used in power stations to generate electricity when they are burnt. So what we basically do is and you don't need to know this for the exam, you burn the fuel, it turns some water into steam, which turns a turbine, okay? And that helps us to generate electricity further down the line. The problem, major problem at the moment, is that when you burn fossil fuels, they release carbon dioxide. And carbon dioxide is a greenhouse gas. Now, does anybody know, and you can write it in the Q&A really quickly anonymously if you do, what is the issue with carbon dioxide? What is the problem? Why is it a bad thing that we're releasing carbon dioxide? What's that big thing we've got to be very aware of at the moment? Can anyone answer me the question in the Q&A? What's the risk of too much carbon dioxide being released? It absolutely can damage nature. Yes, good. What's it causing the earth to do though? I look like an idiot now, I know, but good. It's brilliant. Well done, Madeline. It's creating global warming. Too much carbon dioxide is making the earth too hot. And when the earth gets too hot, then you have the issue of melting ice caps, and you've got the issue of drought and desertification and all of these things that are going to mean that animals can't live in their natural habitats anymore. And eventually it will affect us in terms of humans because of extreme weather, fantastic pollution. It's going to mean that we're not going to be able to grow our crops so well. So it's a real big issue. But today we're not talking about global warming, but it feeds into it. Now, the next non-renewable that we need to look at is nuclear fuel. Now, you could talk for hours about nuclear power plants and nuclear fuel and nuclear energy, because personally I find it fascinating, and I know lots of you do from our lessons when we start to talk about it. Now, lots of governments really like nuclear power, including our own government, as a method to reduce the amount of fossil fuels we use. But it's not without its risks. Now, why do we like nuclear power? So why is nuclear power quite a popular choice with lots of governments around the world? Well, firstly, is it doesn't produce carbon dioxide. So we're not burning the uranium, okay? We are reacting the uranium, which means you're not giving off carbon dioxide as a greenhouse gas. So nuclear power does not contribute to global warming. And also, you generate tons of electricity. Okay, lots and lots of energy per unit of uranium, far more than most other energy resources. But those two things are fantastic. But one thing to be really mindful with nuclear fuel and nuclear energy is that you produce nuclear waste. And nuclear waste is this really radioactive, toxic waste that at the moment, we're not really sure how to make completely safe. We are good at making it slightly more safe and recycling some of it, but ultimately we get left with lots and lots of nuclear waste. And this nuclear waste needs to be stored in lead-lined containers and left for a very long time before it's safe. When I say a very long time, I'm talking hundreds of thousands of years here. Okay, so it really is hazardous for a very long time. Some of it in the past has been buried at sea, and there have been issues with leaking of radioactive waste into the environment. The other serious thing to consider is the risk of release of hazardous materials to the environment. And normally that comes after what we would call a nuclear meltdown. Now, I've included a picture down on the bottom of my slide of the Chernobyl disaster, and that happened, and I can't remember exactly how long ago, but a little while ago. And it happened in what was the USSR, but in what is today's Ukraine. And it's where a nuclear reactor melted down. And Chernobyl, and if you are interested in Chernobyl, please do go away and look it up because it is really interesting. But Chernobyl has been so contaminated with radioactive material that it's a complete no-go zone. Some people, you can go on a tour there, I think, but you have to wear a Geiger counter to monitor the radioactivity, and you can only stay there for a certain amount of time or else it's not safe for your health. There is a really fantastic television show called Chernobyl. I promise I don't work for Sky, but it is brilliant, and it's difficult to watch. So if you're a bit worried about it, maybe it's not for you, but it is fantastic, and it does go into specifically what happened in that meltdown. So that's nuclear fuel. There are some really positive things and there are some really negative things. Just on that quickly, oh, thanks, Ms. Wanstall, 1986 was Chernobyl. There is one thing to note though. The risk of a nuclear meltdown is actually quite low. Obviously, we know about them because they're so damaging when they happen. Another one was Fukushima a little while ago. But they're actually really rare because safety is obviously a huge priority in a nuclear power plant, but it's still something to consider. And to be perfectly honest, Year 11, no one wants to live next to a nuclear power plant. You know, when they look at opening new ones, the local community, you know, absolutely not, because of that risk, you know, because of how dangerous it is. So those are the two non-renewables I wanted to take you through. Now I want to talk you through some renewables, and I've specifically picked ones that are either common in exam questions or ones that I think are a bit more difficult to understand. So I'm not going to go through solar in more detail, but there is some information later on about it. So biofuels, okay? Biofuels are fuels that are made from plant materials. Bio means living things and fuel powers something, okay? So they're a fuel made from plant materials. And there are lots of different types of biofuels. You've got something called biodiesel, which is made from plant oils. You've got bioethanol, which is made from fermenting sugar and wheat. It's like a byproduct, so it's quite useful to be able to use it. And they're burned in a similar way to fossil fuels. So you have the plant material and eventually you burn it to make energy, just like you would with your coal and your oil and your gas. Now, that sounds quite positive in a sense, because you're growing something that can be then replanted, and I can make new plants. It doesn't take that long. And the other thing about biofuels is, yes, when you burn it, it does release some carbon dioxide. But actually, we say that they're carbon neutral, because when you grow plants, they do photosynthesis and they take in carbon dioxide. And with biofuels, the amount of carbon dioxide they give out when they burn is roughly equal to the amount they take in as they grow. But there are other issues with biofuels. First of all, they take up valuable land that could be used to grow food. Large swathes of land are taken up growing plants that will never feed anyone and that will never be positive for our food security and provide those who need it with food. They're just going to be used to be burnt. And actually, There are some people who would think, well, that's a bit of a waste, and maybe we should reduce the amount of energy we use rather than growing so many of these plants just for biofuel. Also, whilst they do release less emissions, if you wanted to use them in your cars and things, you actually have to convert your cars to be able to use them. So very few cars are built with the ability to use things like bioethanol. So it can take some time to convert it. A really well-known case of biofuel being used is the lemon bus. So you're all Brighton based, at least I hope you are, because you go to a Brighton based school. The lemon bus is that yellow bus that rides around, was much more popular when I was at university down here about 10 years ago. And the lemon bus runs on cooking oil. So the lemon bus, and it now has electrical vehicles as well, but it used to go around to restaurants and collect the dirty cooking oil from different restaurants and use that as fuel for their buses, because the lemon bus was trying to be as environmentally friendly as they could be. I remember very clearly being in university, getting on the lemon bus and it just smelling like chips all the time, which was quite nice, to be fair. So that's biofuel. Now, another really common one, and one that you probably, again, know a little bit about already, is wind power. And wind power is renewable. We don't use up the wind as we use it to turn turbines. It's cheap to run. Once you've set it all up, it just keeps going. You need to obviously keep up some maintenance on it, but actually it just kind of goes of its own accord. It's not polluting. Turning the wind energy, that kinetic energy stored from the wind, into electrical energy is not going to pollute at all. Okay, there's no burning of anything, there's no giving off of any gases. So it's really good in that respect. But as with everything, there are pros and cons. Whilst wind power is great that it's renewable and it doesn't pollute in terms of emissions, it's really expensive to set up. The Rampion wind farm, which is the image that I've got down here, which is the offshore wind farm that you can see when you kind of look out the window on a clear day down at the beach, that was really expensive to set up, and it took a lot amount of funding from government to set it up in the first place. And actually, some people were against it for that reason. The second issue with wind, and actually you'll see with lots of the renewables, is they're a bit unreliable. If it's a really still day, you're not really going to get much wind power at all. I mean, that's why we set them up offshore in the middle of the sea, because it's windier out there. Okay, but on days when it's really still, you're not going to get a lot of power from it. Equally, if it's too windy, there are issues there as well. Now, the last two are ones that are more that are really specific to wind farms. The others can be sort of applied to most renewables, but these two are more specific to wind farms. Now, the first is visual and noise pollution. Now, personally, I think wind farms look awesome. Okay, I don't know whether I'm biased as a scientist, but I think it's cool, and I really enjoy in the summer when we were allowed to be outside, going down to the beach and looking at the wind farm. I mean, you can even get a boat to have a look at them. I think they're fascinating. But some people were really, really against them because of the fact that they felt that they would be visually polluting. And that means that they kind of spoil the landscape. Also, if you have them on land, they are exceptionally loud. And so noise pollution is a real issue. Finally, wind farms can be really hazardous to birds. If you put a wind farm up in a place where birds would normally fly in terms of their migration, then you're going to kill birds and you're going to disrupt their migration patterns. And so it's really important that they're planned really carefully as to where they're going to go. The last one in terms of the renewables I wanted to go through in more detail was one called geothermal. And the reason I want to go through this one with you is because ones like solar and tidal, you hear the word, you know what it means. Waves, tidal, solar, you get it. You know what the tides are, you know what waves are, you know what the sun is. Geothermal tends to be the one that in an exam, if you hear it, people tend to go, what? What the hell's that? Right, it's as simple as the word itself. Geo, the land, the earth, and thermal, getting heat. So geothermal power is renewable, and it is the way in which we can use the natural heat of the earth deep underground to heat up water, and that water is then converted into steam and turns a turbine. Okay, that's a really common feature in power stations that we'll look at another time, but it's all about turning a turbine. Now, it's brilliant because we're never going to use up all of that heat under the ground. That heat is there because of the immense pressure and weight of everything above it, and also that solid core in between. But the issue with geothermal is that, again, it's super, super expensive to set up. If you want a brand new geothermal power plant, you better have a lot of millions of pounds ready to do that, okay? And it takes a lot of investment. Some governments wouldn't be able to afford that. Some might not see it as the investment they want to put in at that time. You know, sometimes there are other priorities. Now, there are also some emissions of gases. Not really greenhouse gases. There are a few greenhouse gases, but some sulfur dioxide, for example, is often released, but in smaller amounts than you would get with normal fossil fuels. Also, have been associated with little mini tremors. So I don't know if any of you have heard of fracking, which I really hope you have, but it's one of the ways in which you can get natural gas from the earth. And you basically drill down and you put some water in between the rock and you wibble it a bit. Wibble is not a word. Wobble it a bit, release the gas, and then you collect it. And it creates mini earthquakes in some cases. And that's kind of what geothermal does as well. So there have been some issues with sort of mini earthquakes happening around geothermal plants. And lastly, you can't put a geothermal plant everywhere. Normally, it's got to be at the boundary between two tectonic plates. So geothermal power in the UK, less useful, but it is really good in some parts of, for example, the US, where they are on a plate boundary. This is more geography, but it's still really important. So geothermal, really good, produces lots of energy, more reliable than other renewable fuels, but very expensive and very location specific. So you can't just set it up anywhere. Now, please do not freak at the amount of information that I've just put on the screen. I've been through 5, and I wanted to do that to take you through similarities and differences, etc. But there are lots that the exam board say that you should be aware of. Now, you don't have to learn lots and lots and lots of information about them, but for each of the energy resources, you need to think about what the store of energy is in the first place, whether it's renewable or non-renewable, what it's used for, how much power does it put out, and then what are some of the disadvantages. Now, one of your tasks for this week is to do some revision, and this could be the perfect starting point for your revision. Make it flashcards or mind maps or Google slide revision resources from this. Okay, it's a really good way of revising it, but I'm not going through it because it will be pretty dull. Okay. Now, in terms of that, this is the little segment of the revision poster that I made during the P1 Revise With Me videos. This is the sort of thing that you need to make sure you do. So for renewable and non-renewable resources, do you know examples, advantages and disadvantages, and summarizing them, because that's often what comes up in the exams. So let's summarize ourselves now about the pros and cons of renewable and non-renewable resources. So renewable. They can be unreliable as they often depend on environmental conditions. And also, some produce lots of power, some produce less. Non-renewable, on the other hand, is very reliable and it produces lots of power. Renewable resources produce, on the whole, less or no emissions of greenhouse gases, whereas non-renewable, with the exception of nuclear, do emit a large number of greenhouse gases and are major contributors to global warming. Both can create visual pollution, so can be ugly, basically, on the landscape. Renewable resources can be very expensive to set up, whereas with non-renewable, we're at the point where most of that infrastructure is already in place. We already have your coal, oil, and gas-fired power plants. Really importantly, renewable will not run out. We will have that energy stored there and that energy resource there for forever. And therefore, we will not face a point in the future where we have to worry about what we're going to do next. Non-renewable will run out. And it's important to note that we still get most of our energy from non-renewables as a world population. But where are we now? So what's the case now? Well, for the first time in history, in 2017, more energy was generated in the UK using alternative sources like wind, solar, and hydroelectricity than was using fossil fuels. And that's huge, year 11. In fact, nowadays we have numerous days where that's the case. If there's a very windy or in the summer, a very sunny day, we produce lots of energy through renewable resources. And that's what we need. And how can we push this in the future? How can we promote the use of renewables? Well, one way is that the government often subsidizes green energy initiatives. And what that means to you and I is that the government puts money aside for renewable energy resources and for new buildings that are well insulated. And if you would like to set up more wind farms, etc., the government will help a company to do that because it's really important. Now, what we're going to do now, year 11, and I really want you to stay with me because it's the really important bit, is we're going to now work on some exam questions together. Now, this is low stakes. I'm not going to look at your answers unless you want me to. You can email me them afterwards. What we're going to do is I'm going to put a question on the screen. And in that question, we're going to go through together. We're going to highlight the important words. What would we normally look at in an exam question? And then I'm going to answer it at the exact same time you do. So we're going to spend a few minutes together working on this answer. You will be writing it at home. I am in my home and I will be writing it, but you will see what I'm writing. So if you get stuck, you can always look at what I'm doing and help you. Now, when we do this, it's really important that you have a go, because I want you to learn from what we're doing rather than just watching. You have to take part. Okay, so what I'm going to do now is I am going to share my screen again, which is on my iPad, and I'm going to share something that I've already set up, which is a, let me share first, which is a way of sharing my screen from my iPad. So apologies, guys, you're going to see me messing around with this a little bit now. Okay, so there we go. So what you should see in a second, hopefully, is a exam question which says, describe the environmental advantages and disadvantages of using wind turbines to generate electricity in the UK. So first thing we should be aware of, year 11, is that this is a describe question, okay? And a describe question tells us that we should state some features, okay? We don't need to explain. We don't need to explain why it's an advantage or why it's a disadvantage. What we do need to do, though, is give examples. Now, the next thing we need to be aware of is that this has advantages and disadvantages. Now, this, I'm going to tell you, ladies and gents, is a 4-mark question. So a good idea would be to do 2 advantages and 2 disadvantages. Now, it says wind turbines to generate electricity in the UK. And that's actually quite important, because wind turbines to generate electricity in a super windy place, probably going to be slightly different. So this is a 4-mark question. You need to think about what we've learned so far about renewable energy and what the disadvantages and advantages are. And we need to write an answer. Now, 4 marks in an exam is 4 minutes. So I'm going to start writing now, and I want you to do the exact same at home. Have a go, and we'll share our answers in a second. So I'm going to write on here. You can copy bits of my answer if you want to. It's just about working together. Okay, so 4 minutes, let's go. So I'm going to start with So I've done my 2 advantages there. Notice how I haven't given loads and loads of detail. I've just gone through and highlighted 2 advantages. So that's me half done, but don't worry if you're not, we've had only a minute. I'm now going to go on to my disadvantages. Okay, so we've had 2 minutes, and I really hope that you're doing this at home too, Year 11. I think it's really important you're practicing. Remember, we're still not 100% sure how you'll be assessed at the end of the year. It will be a teacher judgment, but we'll do some form of assessment, and that will obviously include exam questions. So this sort of practice is going to be really brilliant for getting you your grade 5s. So just whilst you're finishing up your answer, I'm just going to show you exactly why this is a 4 out of 4 mark question. So I have got 2 advantages. They are both clear and they're different. So if I said that one advantage is that wind power is renewable, and then I said another advantage is it won't run out, those 2 things mean the same. So I'm not going to get 2 separate marks from that. I've also got 2 disadvantages. Okay, and again, these disadvantages are different. I've talked about pollution in both of them, but one of them is well, I haven't talked about pollution actually in both of them, but one of them is visually polluting. And I could also have said here that they don't produce any emissions at all. Okay, I've already done that. Sorry, I've written an answer and I'm just not even thinking about what I've written. So that is a 4 out of 4 mark question. Okay. Before we move on, do you have any questions about that particular question? Is there anything you want to double check? You know, if you've written something that you want to make sure you get a mark for, pop it in the Q&A. And there's not many of us left, so if you put your hand up, I'd be able to talk to you as well. If not, then I will move on to a second question. We're nearly done, guys. I just want to show you this one more question because it's very similar to this one, but there's one word difference, which is what is really, really important. So what I'm going to do now in my very cool app that I love, so you'll be seeing it a lot, is we're going to look at this question. Okay, now this question is about advantages only, and this question is also 4 marks. So it says, explain 2 advantages of using undersea tidal turbines to generate electricity rather than burning fossil fuels. Now it's 4 marks, but you only need to write about 2 advantages. And the big key thing to look at here, Year 11, is that it says explain. And explain means tell me more, okay? Or why, okay? Tell me why this is an advantage. Tell me more about that advantage. So we only need 2 here. And we know the advantages of renewable resources, don't we? We know that they don't produce any emissions, and they've specifically said as opposed to burning fossil fuels. So what we can also do here is we can think about, well, what are the disadvantages of burning fossil fuels? How can I twist that in a way to make it an advantage of renewable? To be honest with you guys, you don't need to know what a tidal turbine is. I mean, it's just something that spins as the tides come in and out, but you don't need to know that because everything is the same for renewable, mostly. Okay, so let's have a go at this one, and I am happy if you want to just watch along to this bit because we've only got a few minutes left, or if you wanted to have a go on your by yourself. But let's write an answer for this one. So 2 advantages of undersea tidal turbines. Okay, so 1 advantage, and notice how I don't do an elaborate sentence starter. There's no need here, year 11. This is not an English exam, okay? You have to have a good quality of written work, but it doesn't have to be an essay. So one advantage is that it is renewable. Now that is a description of an advantage. So now I need to explain why that's an advantage, okay? And it's an advantage because it means, or this means I should say, there we go. This means it will not run out. And then what I could do, just to make my answer even, tighter, is I could say, unlike fossil fuels, because they will run out, won't they? Now that would be worth 2 marks, because I have said what the advantage is, I've stated the advantage, then I've explained why it's an advantage. Now the second advantage I'm going to go through, another advantage, and I'm going to go back to that pollution one again. It doesn't emit harmful gases, okay? So another advantage is that it doesn't produce, and I'm going to be specific here because I talked about fossil fuels, I'm going to say it doesn't produce carbon dioxide. So that's me describing the advantage, but let's explain why. Why is that important? Okay, this is good because carbon dioxide is a greenhouse gas which causes or leads to global warming and climate change. So because the question, and I apologise if my handwriting's getting a bit scrawly, it's a bit difficult to do both of these things. If this was a question in the exam, you've got a perfect 4-mark answer there because you've stated your 2 advantages. That's the first thing you need to remember, year 11. You need to make sure that you do what the question says. But you've not just stated what they are, you've explained it. And if you were in an exam and you were stuck and you weren't sure how to explain it, you'd still get 2 out of the 4 if you just identified 2 advantages. Now, there was one more, but we're not going to have time to do it. You can see that's over here somewhere. There we go. But we're not going to do that one now. We are going to just quickly recap on what we have to do this week. And then if there are any questions, I will have you ask me. So apologies. Oh, okay. No, that's my video. Don't need to show you that right now. Okay. So this week, year 11, just as a reminder, you're going to watch the webinar, which you've already done. Well done. Tick it. You're going to complete the quiz on your Google Classroom. And then you're going to go back and make additional revision notes from the video that I just accidentally clicked on. So flashcards, mind mapping, etc. If you've done that, you've submitted pictures to your teacher, you can then have a go at an extension task, which will be some additional questions, which will be in your Google Classroom. If you have any questions, please stay and ask them. Equally, if you have any comments about the exam questions together and whether or not you liked it or whether you think we should do it earlier on, etc., please do let me know. I really want to work on this to make it as useful for you as possible. It's been brilliant seeing you all here, year 11. Unless you have any additional questions that you want to go over, you are free now to leave and to have a go at that quiz and just get yourself sort of familiar with what you need to do next. But thank you for coming. It's been a pleasure to speak at you for the last 45 minutes. There are 2 of you left. Is that because you have any questions? Okay, so as we don't appear to have any questions, Ms. Wanstall, I'm going to end the webinar there. Thank you for helping.
I didn't really help, but I was here.
It was here. You were here, miss. You were. It was very important. You told me when Chernobyl happened. And without that... Okay, brilliant. Well, thank you everyone for coming and we'll see you next week.